Here we have some more word problems that involve quadratic equations. This first one is a pretty typical type of problem where you drop something and it accelerates to the ground due to gravity, and we want to know how long it takes before it hits the ground. It says here the distance h traveled in t seconds by an object dropped from a height is height equals 16t squared. If an object is dropped from a height of 27 feet, how long will it take before the object hits the ground? So you can think about it this way. The height, 27 feet, equals 16t squared. But we want to find when that height is 0. So we're going to subtract 27 from both sides, and we get 0 equals 16t squared minus 27. And then you can go ahead and solve the quadratic there. I think I'm just going to use the quadratic equation. It's going to be pretty easy because I'm missing a t term, so I'm missing b. So this would be 0 plus or minus the square root of 0 squared plus 4ac, or minus 4ac, but there's a negative sign here, so I'm just going to say plus 4 times 27 times 16. And let's see, 4 times 27 times 16, that would be, oh, and that's all over 2a, so that's all over 32. So 4 times 27 times 16, let's see, I might rearrange that as, so 312 times 4 times 6, I might say 64 times 9 times 3. So that's the square root plus or minus the square root of 64 times 9 times 3. We're going to leave the 3 inside. We'll take the 64 out, make it an 8. We'll take the 9 out, make it a 3. So that's plus or minus 24 times the square root of 3 over 32. And since we're talking about the amount of time, a negative time doesn't make sense, so we'll just look at the positive result. And this would simplify down to 3/4 times the square root of 3, and this is seconds. All right, let's try another one. This one is particularly tricky and involves a lot of manipulation. So this one says, a wire that weighs 9 ounces per meter is stretched from point D to point B. So 9 ounces per meter. Another wire is stretched from point B to point A that weighs 7 ounces per meter. 7 ounces per meter. If you know that the total weight of the two wires is 170 ounces, how far is it from point B to point C? At first, those two things seem unrelated. How are you going to get from one piece of knowledge to the other? We do have a couple of other clues. We have this total length here. We also have this length here. We know this is a right triangle. So the Pythagorean theorem is going to come in here somewhere. So let me just start writing some equations. Let's write out what our Pythagorean theorem would be to solve for, well, these sides that we don't know. So it would be a squared plus b squared equals c squared. So let's just put 9 squared plus the side bc squared equals db squared. Now, what other equation can we make here? Well, they're telling us the weights of these wires and what they add up to. So I know the weight of this wire plus the weight of this wire adds up to 170. So it's really the length of AB times the weight per meter. So right, so 7 times AB plus, same thing over here, 9 times dB equals 170. So that's something else we know. Although it would be nicer if, because I've got BC and dB up here, if I had BC and dB down here. I've already got dB. If I can get this to be BC, then I've got two equations with two variables and I can solve. And I can do that because I've got this relationship here. So AB is this little chunk of 17. So all I have to say is 17 minus BC equals AB. And I can put that in there. So I get 7 times 17 minus BC plus 9 times dB equals 170. Now between this and this, I've got a system of equations that I can go after. And I think the way I'm going to do this is to solve this guy for dB, because all I would have to do is take the square root of both sides. So dB equals the square root of 9 squared plus BC squared. And that I could put in right there, and then I'd have one equation in terms of BC. And that's actually what we're trying to find. So that's pretty good. let's try that. There's a lot to do here in terms of calculation. So 17 minus BC plus 9 times dB, which we're defining now as the square root of 9 squared plus BC squared, equals 170. Now the next thing I want to do is isolate this square root and then square both sides. So let's do that, and while I'm at it, I'm going to do a little bit of multiplying through. So let's call this negative 7 BC plus 119. I'll move the 170 over here, minus 170 equals, and I'll move this over here, negative 9 times the square root of 9 squared plus BC squared. And we can simplify a little bit over here. So this is negative 7 BC minus 51 equals negative 9 times BC squared plus 9 squared. I just reversed those terms, but that's the same thing. And at this point, I think I'm going to go ahead and square everything. And over here, we'll get 49 BC squared plus 714 BC plus 2601. And over here, we'll get 81 times BC squared plus 81. All right, we've come a long way, but we've still got a little ways to go. We've got one variable. We can multiply through that 81, do some rearranging. After I do all that, I think I get negative 32 BC squared plus 714 BC minus 3,960 equals 0. And at that point, I would probably use my quadratic equation solver and see what I get. And what I get for BC is either 10.3 or 12. And that happens with triangles. There are often two triangles that can solve a particular set of circumstances. So BC could actually be either one of these. And that's going to be your answer.